Today's webinar is on making sense of Cat M1 and Cat M2. My name is Jeremy Cowan. I'm editorial director and co-founder of IoT Now, and I'm your moderator today. And I want to thank the hundreds of you who are going to join us live today around the world. We've got a very interesting discussion for you, brought to you by Altair Semiconductor. And we have some valuable experience and expertise to call on. I'd like to introduce you to Itai Lusky, who is Senior Director of Strategic Product Marketing at Altair Semiconductor. Welcome, Itai.
It is good to be here, Jeremy. Thank you.
So today we're discussing how, as IoT and M2M growth continues to accelerate, the need for more cost-effective and more power-efficient chipsets is being impacted by two competing technologies. And they are Cat M1, also called Cat M, and Cat M2, known as NB-IoT, or narrowband IoT. The webinar is being recorded, and you will be able to access it in the next 48 hours via iotnow.com. Before we start, I just want to remind you that this is a truly interactive webinar. We really want you to know exactly what you think. So in a moment, we'll have the first of two live polls, and you'll be able to see the results immediately. And at the end of Itai's presentation, I will put your questions to him. So starting right now, you can begin to send us your questions. And you can carry on doing that at any time during the webinar. All you have to do is just click on the questions button and type them into the window. I will put as many questions to Itai as time allows, and if we run out of time to put questions to him, obviously the remaining questions will be passed to Altair to answer offline. Anyway, please send me your questions now. And if you're having any technical issues with audio or slides, you can also use the question window to get advice from our technical support team. Could you advance to slide 4, please? Now it's time to hear from our speaker, Itai Lusky from Altair. And soon we will break for our first poll. Itai, over to you.
Thank you, Jeremy. So today we are talking about technologies of category M1 and category M2. Today, LTE Cat 1 is the technology that has the most power efficient and performance with the cellular IoT connectivity. However, moving forward, two new technologies are being introduced by 3GPP in Release 13 activity. The first is Cat M1, as you said, that previously was called Cat M. And the second is Cat M2, known also as NB-IoT. Today, as is commonly in few cases known in the ecosystem, Cat M2 is perceived to be superior to Cat M1 with several key KPIs, namely coverage, power consumption, and cost. Altair today is designing its next generation Release 13 chipset that will support both standard, both technologies with narrowband support. What we would like to discuss today is to discuss those three KPIs, technologies or topics from technical point of view, and show you that several items that are being perceived as superior by Cat M2 are not exactly as such, and that we will discuss during the next few slides. Back to you, Jeremy, for the poll.
Thank you, Itai. Well, the first poll is an interesting one. The question is, are the products that your company is planning to develop or deploy based on Cat M1, Cat M2, both of those, or you don't know yet? So please take a moment to answer one of those options. That's either Cat M1, Cat M2, both, or you don't know yet, and we'll see what results we get from that. So that's, are the products that your company is planning to develop or deploy based on Cat M1, Cat M2, both, or you don't know yet? I'm sure people have had time to answer, so let's go to the results. Well, that's quite conclusive. We can already see that over 60% say that they don't know yet, and 24.5% indicate that it will be both technologies. 7.5% each for Cat M1 and Cat M2. Before we move on, Itai, is that the kind of expectation that you had of this poll?
Actually, yes. I think that there is some confusion in the ecosystem with regard to the two technologies, what each one brings with it, what are the merits of each technology. And I hope that our seminar today will provide some more insights that will allow a convergence in the ecosystem to some direction. Okay.
Well, more will become clear as we go on, and we do have another poll towards the end of your presentation. So I look forward to the audience's response on that. But now over to you, Itai, to continue your presentation.
Thank you, Jeremy. So in the next few slides, we will go and discuss the comparison between Cat M1 and Cat M2. I would like to begin with some baseline of comparison for key properties between the two technologies. Later on, in the following slides, we will touch base more in depth into technical comparison of some of the KPIs that I mentioned. But let's start with some comparison between the technologies, as you can see in this slide. Starting with the bandwidth, Cat M1 is 1.4 megahertz versus Cat M2, which is narrowband 200 kilohertz. So that better fits operators' GSM spectrum assets, for example. From mode of operation, Cat M1, which was derived directly from the LTE, works with in-band LTE, while the Cat M2 provides three scenarios, both in-band LTE, work at the guard band of the LTE, and also a standalone feature, meaning usage of legacy GSM bands. Both technologies uses a single RX topology, which is a change from category 1, for example. From duplexing perspective, the Cat M1 uses both HFDD, FDD, and TDD, while Cat M2, at least at this point, is HFDD only. TDD is still under discussion. If we talk about the access, starting with the downlink access, so the Cat M1 uses access of OFDMA with 15 kilohertz subcarrier spacing, and same goes also with Cat M2. Going for the modulation, Cat M1 has both QPSK and 60 QAM, while Cat M2 has QPSK and below, pi half BPSK and pi over 4 QPSK. Going towards the uplink, then the Cat M1 has a SAFDMA with 15 kilohertz subcarrier spacing, and Cat M2 can support two approaches, both single carrier FDMA with 15 kilohertz subcarrier spacing, but also single toll transmission, which we will see later on provides it some good merits with regard to the Cat M2 uplink performance. Going for the uplink modulations, again, we can see some more availability from Cat M1, which supports both QPSK and 16 QAM versus QPSK by Cat M2. And that translates to the peak data throughput that Cat M1 can reach, assuming HFDD, 375 kilobits, while CAT-M2 has lower than that, approximately 50 kilobits per second. Going towards the uplink transmit power, both technologies support 23 dBm, though it is easier to achieve that with CAT-M2 due to the single-tone transmission that I mentioned earlier. CAT-M1 allows also 20 dBm TX power. This is a new power class that was added, where the lower power class is under discussion with CAT-M2. As for time to market, and I believe this is somehow subjective, possibly subjective information, but CAT-M1 is in a more mature stage because it started a long time ago. So we estimate that to have 6 to 9 months of advantage from time to market compared to CAT-M2, that several aspects with regard to standardization are considered to be delayed towards the release 14. So this is a high overview with regard to comparison between the two technologies. Moving to the next slide and comparison. Now let's try to dive into the actual parameters which are important for applications, because you as operator or device manufacturer that needs to choose what is the right technology to move forward probably are being interested by the performance, about the sensitivity, about power consumption, about cost, about capacity, about mobility, voice. So those kind of items are the ones that we try to address in this slide and compare between the two technologies. Some of the items are strictly derived by standard definition, so there is no question about. Some of them are being derived by analysis that we will see during the next few slides. So whenever I will reach that topic that requires further analysis, I will mention that. So don't take it for granted. Just wait for the next few slides that describe why we say so. I will start with the performance, the uplink performance and downlink performance that is being characterized by the throughput that you can transmit per dB of data. So starting with the uplink performance, our view, and we will demonstrate that slightly later, is that CAT-M2, assuming 23 dBm, is similar to the performance of CAT-M1 using 20 dBm, and that means that it is worse than CAT-M1 if it uses 23 dBm. And the main reason is ability that was added to the standard with CAT-M1 called frequency hopping. We will see some simulation results down the road that demonstrate that. So again, if to get similar performance, you need 23 dBm for CAT-M2 versus 20 dBm in CAT-M1, and that means that if you take same transmit power of 23 dBm, then CAT-M1 will provide better uplink performance. Going for the downlink performance, so since CAT-M1 is 6 times with larger bandwidth, that means 8 dB, that translates to a better downlink performance compared to CAT-M2, at least for in-band deployments. As discussed earlier, CAT-M2 can support 3 different deployment scenarios. At least for the in-band deployment, we will show that CAT-M1 has better downlink performance than CAT-M2. With regard to cost, there is a strong approach, let's call it, in the market that CAT-M2 is significantly lower cost than CAT-M1. We will discuss that as well. We agree, indeed, that CAT-M2 is lower cost, but the gaps are not dramatic. We estimate them to be approximately 2%, and we will discuss that down the road. Moving towards power consumption, again, we need to separate between downlink and uplink performance. Starting with the downlink power consumption, we will analyze and show that CAT-M1 is approximately 50% in downlink power compared to CAT-M2. And we will explain why is that. And that is mainly derived from the lower bandwidth that CAT-M2 has. That means that it requires longer transmission time, and this is a dominant factor with regard to the power consumption that is being used. When we go for uplink power consumption, here the single tone of CAT-M2 that is standardized and part of the definition provides benefit for CAT-M2, which we estimate to be around 20% better power consumption in CAT-M2 compared to CAT-M1 in the uplink. This is true in poor coverage scenario. If we go for good coverage scenario, then CAT-M1 has better performance and in sense of power, and we will discuss that as well. Now, when we talk about uplink, downlink power consumption, that may be interesting, but what is really relevant is what is the applicability into the performance or scenarios. So two typical definitions are added by the standards called PSM, power save mode, and EDRX. Usually, most IoT devices, EDRX is the scenario which is more applicable to them. And since EDRX is downlink dominated, that means that it has better or benefit for CAT-M1 over CAT-M2. Because as discussed, that is CAT-M1 has better power consumption in downlink than CAT-M2. Talking about capacity, so in overall, that is derived from what we talked earlier. CAT-M1 has better downlink capacity due to better performance, where CAT-M2 enjoys better uplink capacity due to the single tone. What is important to mention with regard to the single tone is that in 3GPP in release 14, this kind of capability is likely to be added also for CAT-M1. In that sense, one of the major benefits that CAT-M2 has today over CAT-M1 may be diminished. Moving towards mobility, then CAT-M1 has full mobility support versus CAT-M2 does not have connected mobility, only support idle mode reselection. So that means that applications that requires connected mobility are not applicable to use CAT-M2. As for voice or VoLTE is something that is being discussed if it can be supported with CAT-M1. This is not finalized yet. This is under discussion with regard to if it can support what are the conditions for that. But according to our view, this is a doable capability within the CAT-M1. For sure, this is not feasible towards CAT-M2. So application which requires voice support may want or need to work with CAT-M1. If we talk about applications, then there are several applications that can be characterized by each technology, CAT-M1 versus CAT-M2. So CAT-M1 can be used towards the M2M, trackers, wearable, voice-enabled devices. Subset of that can be applicable also for CAT-M2, namely the M2M and trackers. We believe that surely for voice-enabled device, but also for wearable that likely will need higher throughput, CAT-M1 will be more suitable technology than CAT-M2. An interesting talk is about market acceptance. So that is something that is being separated around the globe. North America is tending towards CAT-M1 versus China and Europe are tending towards CAT-M2. And this is an interesting approach, what will become the dominant. And I think that that can be very well reflected also with the short poll we did at the beginning. Most of the audience say, I don't know. Half said CAT-1. Some said, half said same percentage said M2. And that shows where the ecosystem is today. And whenever technology wins, as I said earlier, Altair approach is to develop a solution that will fit both technologies. It is important that a single stream will move forward to enjoy the ecosystem strength. So now let's start and discuss the 3 KPIs that I mentioned earlier. I talked about performance comparison, where I said I claimed some items with regard to downlink performance, uplink performance. I talked about power, and I talked about cost. So the next few slides will go over those items and analyze them. And we try to do that in a mathematical way to support those discussions. So let's start with Shannon. Shannon was a wise guy, and it's a good habit to start talking when you analyze things, starting from this approach. So for coverage limited scenarios, SNR is low. This is the place where we need to analyze things. And according to Shannon theory, and we can see that at the upper right-hand side of this slide, in low SNR conditions, data rate is linear to the signal power, and it is independent of the bandwidth. We can see from the short description at the upper right side of this slide that the bandwidth is appearing both at the numerator and denominator of this equation. Hence, the capacity is not a function of the bandwidth. So that triggers an interesting question, because when we compare 3GPP definitions of the MCL, which is essentially shows about the performance or how loss can you observe while still receiving your data, we can see substantial gap between the MCL which is published for CAT-M1 versus the MCL which is published for CAT-M2. The numbers for CAT-M1 are 155.5 dB versus 164 dB for CAT-M2. So that represents almost 10 dB of MCL gap in favor of CAT-M2, which theoretically shows tremendous benefit for CAT-M2 over CAT-M1. But we just said 2 minutes ago that according to Shannon theory, the performance or capacity of the network should not be a function of the bandwidth. So how come CAT-M1 provides such benefit on paper compared to CAT-M2 provides such benefit compared to CAT-M1? So the answer is quite simple, and we will see that with some simulations in the next 2 slides. We are talking here about 2 activities, although being done in 3GPP, but with different working groups. So they took different assumptions. They took different assumptions for the TX power, different assumptions for the noise figure, different assumption for the bit rate, where this definition is being, the MCL is being calculated. And by that sense, it opened a gap between the 2 technologies, which is not a real difference, just a matter of way of comparison. So if we look at the table at the bottom right-hand side of this slide, we can see the differences. I already talked about the MCL, the target MCL, 155 versus 164. But we can see also different assumptions for the noise figure. For example, in CAT-M1, in the downlink, 9 dB noise figure was assumed, compared to only 5 dB in CAT-M2 in the downlink. And same goes with the uplink. 5 dB were assumed in the uplink of CAT-M1 versus 3 dB in the uplink of CAT-M2. So only due to that, some gap is being opened of several dBs between the 2 technologies, but there is no real reason to have different noise figure between those 2 technologies. So this is one point. The gap is even much larger if we look at the TX power, because the assumed transmit power of CAT-M1 versus CAT-M2 in uplink or downlink, mainly in downlink, that opens a huge gap, because if in CAT-M2 they talked about 43 dBm at 180 kilohertz, for CAT-M1 the assumption was only 46 dBm but over 9 megahertz. So that opens a dramatic difference between the transmitted power from E node B side. So we will show shortly within the simulations performed, if we compare apples to apples, what is the real performance difference between the two technologies. But before simulations, let's see theoretically what we would expect. So what would we expect from apples to apples comparison? So for Uplink, when we use the same power class, 23 dBm, and same noise figure, and same MCL, and some noise figure, then the same MCL the MCL should be similar to both technologies. And this is a direct derivative from the Shannon theory. If we talk with the same conditions, then the capacity should not be a function of the bandwidth. And that is what we expect here to happen. For the downlink, when we use the same noise figure and the same TX power density, then the MCL should be better for cut M1. And the reason is due to the 6 times higher signal power, because the bandwidth is larger by 6 times, and spectral density is flat. There are some boosting options, which we'll discuss later, but let's put it aside for now. So transmitting 6 times the energy will provide 6 times more signal power, hence we would expect higher performance. The above is for 8WGN channel and for the same coding schemes if we compare. If we consider also the frequency hopping, which I mentioned earlier, for those who are not familiar, frequency hopping is a feature added by the standard which allow the transmission of the data to hop between different frequencies, hence provide better immunity to fading channels. That technology was added to CAT-M1 standard and eventually was not added yet for CAT-M2 standards. So that provides some added performance for CAT-M1. Also some differences between different of coding schemes that are being used by the different technologies. That opens even better gap in favor of CAT-M1 with regard to the performance. And let's see some graphs. Always best to look about some graphs. So I'm starting with the Uplink performance. So in this slide, we can see 2 graphs. The upper graph is how things are being defined by the 3GPP. Okay? So the upper graph shows the CAT-M1 and CAT-M2 with 23 dB APA under 3GPP assumption, namely CAT-M1 assumes 5 dB of noise figure, while CAT-M2 assumes 3 dB of noise figure. But CAT-M1 has frequency hopping, while CAT-M2 does not support that. So those 2 conditions are being represented in this slide. And what we can see here, although it is not an apple-to-apple comparison, that performance is approximately the same, because the 2 dB in favor of CAT-M2 due to the noise figure are being compensated by the gain being added by the frequency hopping. However, what we believe is more important or relevant comparison is indeed to compare apple to apple, meaning assume same noise figure for both technologies. And here we can see quite clearly that about 2 dB gain is being foreseen for CAT-M1 over CAT-M2, and that is due to the frequency hopping that we talked before. The conditions where these simulations were run can be seen in this slide, just for sake of complete information, meaning what kind of channel, what channel estimation was that, if some impairment were introduced to the system. But the conclusion is quite clear. If we compare apple to apple between CAT-M1 and CAT-M2, then the performance of CAT-M1 is better than CAT-M2 by approximately 2 dB. And we explained why. By Shannon theory, we should expect the same performance. But on top of that, additional feature was added for CAT-M1, which is the frequency hopping, which, at least in this scenario, but we believe this is a typical case for other channels, added some benefits or performance gap in favor of CAT-M1. I will move now to to do the same towards the downlink. And let's see in the downlink is the comparison. So starting with the upper graph, here again we compare cat M1 compared to cat M2 under the conditions of 3GPP according to the definition, namely 9 dB as a noise figure for cat M1 compared to only 5 dB noise figure for cat M2, and different transmit power from input B side, meaning 46 dB MTX power across 9 MHz versus 43 dBm across 180 kHz. What we can see in the upper graph is substantial benefit of cat M2 compared to cat M1, and this is indeed represented by the MCL numbers which are quoted by each standard. We saw in previous slide that we have almost 10 dB, more accurately slightly less than that. We saw that there is potential of almost 10 dB better performance of cat M2 over cat M1. However, this is a very misleading comparison, we believe, because the parameters are very different from each other. So the middle graph, if we compare apple to apple, namely same noise figure, we can see that the picture is completely different. Cat M1 has an 11 dB gain over cat M2, and we can easily explain this gap because we have 6 times larger bandwidth, which provides almost 8 dB gap. We have the frequency hopping properties, which adds additional 2.5 dB. And there are some difference in the processing gain, which can be added by the different coding scheme which are being used, which represent additional around 0.7 dB. So overall, there is 11 dB performance gap in favor of cat M1. This is not the last analysis because cat M2 provides also power boosting, and cat M1 provides as well, but smaller one. So if we allow the numbers which are enabled by the standard, which is 3 dB of power boosting for cat M1 and 6 dB, up to 6 dB of power boosting of cat M2, that shrinking the gap from 11 dB to around 8 dB, but the gap is still there. So the conclusion here, as well as we saw in the previous slide, is that in the sense of performance, which translates to the sensitivity or the robustness, or we can call it different names, cat M1 is superior to cat M2 due to the larger bandwidth, due to the definitions of the standard like frequency hopping and different coding schemes. And this is something that needs to be accounted while getting decisions of what technology to support. Again, we are trying to be objective here, not to provide a bias towards one direction or the other. And as I said, Altair are designing solutions that will fit very well both technologies. But we do think that it is extremely important that the ecosystem as a whole will get the right technical details in order to make the right decision. And we do think that it is very important that at the end of the day, there will be a leading technology that will gain the benefit of the ecosystem and scale. I would like now to touch base the second topic that I mentioned at the beginning, which is cost. So from cost perspective, this is again one of the topics which is being claimed very strongly, that NB-IoT is dramatically lower cost than cat M1 or cat M, which was previously called. So let's discuss this topic as well. What we can see in this slide is a block diagram of a typical module. And the block diagram of a module is almost the same either if this is CAT-M1 or CAT-M2 feature. So let's review the different blocks here. Obviously, we have an antenna. We have some front-end components. I'm starting to review from left to right in the pictures that you can see. So starting from the left, we have antenna. We have front-end components, either filters, switches, and so forth. We have a PA. We have receiver and transmitter RF portions, some analog baseband, some PHY physical layer signal processing. Typically, we have a 3GPP and added protocol CPU to run the MAC, the L2, L3, whatever is needed. We have a block for IOs. Different IOs may be needed for different IoT applications. We may want to add a GPS into the module, and it may have its own antenna port. We will need some external memory, potentially some MCU to be used by the user to manage the applications. And if I go for the lower part of this block diagram, then we have the power management units, we have crystals, a SIM card, and so forth. So most of the cost is not impacted by the specific PHY technology or the bandwidth, as low as apples-to-apples comparison is being used, because you can see here, at least our view, that all the blocks which are being marked in white has no or minor technology impact on cost. And by technology, obviously, I mean the comparison between CAT-M1 and CAT-M2. What does make some change is the baseband, because processing of 200 kilohertz or 1.4 megahertz does have some change or difference. But this is quite a minor difference. What is important in the sake of these discussions is indeed to have apples-to-apples comparison, because we need to compare the same number of bands to be assumed. We need to compare the same added protocols or functionalities beyond the 3GPP, like provisioning, firmware upgrades, and so forth, and any other requirements on top of the baseline modem, like MCU or application memory needed or GPS, etc. That does make a change, but these changes can be done using the same standard by different definitions of the module properties. Those are not changes that are being reflected from one technology to the other. From analog or RF section, the cost is dominated by the blocking emission specification rather than the channel bandwidth. And in fact, that may be even more demanding for CAT-M2, but we don't have time to get into that today. But from RF or analog section, those blocks should not have dramatic different cost delta between CAT-M1 and CAT-M2. The baseband PHY DSP is scalable according to the bandwidth. However, cost is already down very much within today's technology to around gap of 10 cents approximately, which is maybe 2% of the cost of the module in that sense. And if we look further down the road, let's say 3 years from now, and taking Moore's law and the shrinkage that is still expected to the ICs, that gap will even become smaller. So in that sense, also from cost perspective, the differences between the two technologies, according to our analysis, and it's more than analysis, this is a design which is in a very advanced phase, the difference is very small. And again, as long as you compare apple to apples, this is the key fact in that discussion. I'm approaching the end, and I would like to get into the power consumption state. And in that sense, I would like to analyze also the power consumption differences. And I will try to make it brief to allow some time for Q&A. So in this slide, we can see some analysis for the power consumption aspects, both in downlink and uplink. What we can see if we take the middle column of the downlink traffic, in general, what we need to understand is if I'm allowed to transmit with high speed, that provides me ability for less energy per packet. if we examine the picture below, we can see that for Cat-M1, because of the higher throughput that can be supported, higher bandwidth, higher modulation, then the length of the burst is much smaller than the length of the expected length of the burst of Cat-M2. And even if the spectral density of transmitted data is slightly higher, as this picture depicts, still the integration of times versus spectral density is smaller, meaning transmitted power is much lower in Cat-M1 versus Cat-M2, and we mentioned that it is estimated to be about 50% of Cat-M2. If we go for the uplink traffic, here we need to analyze different scenarios, either good channel conditions or bad channel conditions. So the good channel conditions, the story is the same as in the downlink. Even if you have higher spectral density in your transmit power because of the single carrier of DMA, which is less efficient than the modulation which is allowed by Cat-M2. So even if the blue curve is higher in its height compared to the red curve, still, due to the higher throughput that can be transmitted with Cat-M1, the total time is smaller and the total transit power is lower. However, if we go to bad channel conditions, then in that case, Cat-M1 is worse than Cat-M2 because the Cat-M2 enjoys the single tone capability which is being defined. So if I summarize also this slide, also for power consumption, we believe that for the downlink, Cat-M1 is superior to Cat-M2 by about 50%, and Cat-M2 is better than Cat-M1 in bad channel conditions. Jamie, maybe it's a good time now to go to our second poll.
Yeah, I think it's a very good time, Itai. Thank you. My word, there's a lot to take in there. And before I forget, we have got a lot of opportunity for questions after the poll and after Itai's summary. So don't forget to send us your questions. We have some good ones already, but send us yours. The next poll, the second poll, is now up on your screens, and it says, what, in your view, is the most important parameter for next generation Release 13 IoT chipset? So the first option is power consumption, the second, cost, the third, size, and lastly, design flexibility. So just to give you time to answer that, let me run through that again. What, in your view, is the most important parameter for next generation R13 IoT chipset? Is it power consumption, cost, size, or design flexibility? Well, given that people have had a chance to answer, let's see the results. And by a good margin, cost is the leading factor. By the judgment of most of our audience, it is the most important parameter for nearly 47% of our audience. 36% say power consumption, 14% pick out design flexibility, and only 2% would opt for size as the most important parameter. Itai, is that in line with your expectations?
Yes, that is in line. I would say slightly surprised because I had assumed that cost will be by far the dominant KPIs that will be interesting. So in my view, the fact that 38% show that power consumption is important is interesting.
Yeah, that's a very fair point. Well, those are the results, and we will get to your questions in a minute, but there is a short summary that Itai is going to give us, and then we come to your questions. And, of course, any questions that we don't manage to cover in the time available to us, and there are plenty, we will pass, of course, to Altair, and they will, I'm sure, want to come back to you offline. So, your summary. Itai, over to you.
Thank you. So at the beginning of this session, we presented two technologies, CAT-M1 and CAT-M2, that are being planned to address the cellular IoT market. Both technologies come from 3GPP in Release 13, and there are some market assumptions with regard to key KPIs of the differences between the two technologies. During our session, we tried to analyze mathematically, by simulations, what we should expect and what we see in reality for those important KPIs in the sense of coverage, power consumption, and cost. And what we saw during this presentation are the following. Starting from coverage, the market perception is that CAT-M2 provides better coverage compared to CAT-M1 by almost 10 dB. What we showed, both by analysis and simulations, is that in downlink, CAT-M1 has about 8 dBs better than CAT-M2, and this is very significant, 6 times better than CAT-M2 for in-band deployments. We would expect similar downlink performance when we compared to standalone development, but we did not focus too much in that in this slide. And as for uplink, we saw that in CAT-M2 at 23 dBm is approximately similar to the performance of CAT-M1 at 20 dBm, and it is worse than CAT-M1 at 23 dBm, and that is mainly due to the frequency hopping that we discussed. From power consumption, the market perception is that CAT-M2 provides much lower power numbers compared to CAT-M1, and we showed and analyzed why this picture is not accurate in our view. And in CAT-M1, we estimate that in downlink, we estimate that CAT-M1 is approximately 50% more efficient than CAT-M2, and CAT-M1 is more efficient is more efficient than CAT-M2 with good coverage conditions, and we explained why. This is actually the same scenario or same analysis like in the downlink. And when we go for the uplink in poor coverage, then CAT-M1 is 20% less efficient in uplink power compared to CAT-M2. And this is also likely to be closed in Release 14. So we saw in the poll that power consumption is an important KPI for many of the audience. Those numbers or this analysis is something that need to be taken into consideration. Going towards the cost, then the perception is that CAT-M2 significantly has better cost structure or lower cost than CAT-M1. And what we believe is that both technologies carries very similar cost structure, and the points where CAT-M2 is better than CAT-M1 are existing, obviously, but that represents several percent of module cost change. Again, a key KPI, a key topic here is that it is that way if we compare apple to apples. This is very important things to say. Same bands, same operator-added services, same GPS with or without GPS, MCU, and etc. And from network aspects, CAT-M2, the perception is that CAT-M2 provides better capacity and better fits the GSM spectrum, and that is true because CAT-M2 has better capacity in the uplink due to the single-tone features, and it better fits into GSM spectrum. CAT-M1 has better capacity in the downlink due to the frequency hopping and the turbo coding. To summarize, Altair is developing solutions that will address both items, and both CAT-M1 and CAT-M2. What we want here is to discuss the key KPIs so each operator, each device manufacturer can get its decision in the right manner. So thank you.
Itai, thank you. You've given us a heck of a lot of food for thought there, and people have been very busy with their questions. So let's turn to those without further ado. We've got a good few minutes, but we're going to have to keep it moving quickly to get as many questions done as possible. Before I forget, I can also confirm that slides of this event will be available after the webinar on request to Altair. So if you want to know more and if you want to see more in more detail what you've seen today, just get in touch with Altair and they'll be pleased to share the slides with you. Now, the first question from a large software company: how are the MNOs going to handle billions of small devices and sensors, even with M1 and M2, comparing with the coexistence with LPWAN? Itai, can you give us your thoughts on that?
Yeah, so that is a real good question, because we are here in a very competitive market, and obviously both Cat-M1 and Cat-M2 were designed in order to provide as good solution as possible to the LoRa and Sigfox and the other technologies which are competing. This is the goal of those activities, and that can be done once if the right price point are being achieved and the right technologies. What we think is that it is very important that the market will get to a unified approach. This separation between the different technologies, and again, without saying what is the right one, there are merits for each direction, which I showed in this presentation. But the separation to the different technologies is something that may prohibit the cellular IoT to efficiently provide solution compared to the other technologies.
Yeah, that's a fair comment. The next question is, based on your experience with MNOs, mobile network operators, Itai, are they planning to repurpose the spectrum from GSM and CDMA EVDO for Cat M1 and M2?
Yes, I think that we can clearly see this approach. Some operators has openly declared, and they do that few years in advance, that they're going to sunset their 2G networks and evacuate the spectrum towards an more advanced technologies, and LTE is obviously the right approach. So this is something that is happening. It's happening real time. It's happening also during 2016. It's not something that will happen in the future. And I'm quite confident that we'll see that more and more down the road.
There's a very short question here, Itai. What is the date expectation for release 13 and 14? What date do you expect these to be out?
Yeah, so typically release 13, the goal is to conclude that quite in the near term, in the next few months. As I said, Cat-M1 is a more stable status, and final definitions of the tests are being done. Cat-M2 still have topics to conclude, and some of them may move into release 14. But the general idea is to conclude the release 13 quite shortly. And typically, if we look from the history, I would expect early devices to be available at the market starting from end of this year, but more likely by middle of next year. And this is more or less the time that takes from standard closure to ecosystem readiness. And we should expect release 14 to come with approximately 1 year later.
Okay. Good question here, and this is the $64 million question. What networks will support Cat M2? Are they existing carriers, or will these be new proprietary networks like 802.15.4 has evolved?
No, I think that Cat M2 or Cat M1 are things that current operators are being discussed worldwide. We have been spent quite some time to discuss that with key operators which we are engaged with. And the picture that I see is quite mixed, as I depicted in my slides. Some operators are going for M1, some are going for M2, and most of them, as I see it, are looking to the right and left and want to see what will be dominating the market. And this is where we stand today.
Good question from a telco here. What about the precision of geolocation?
About the precision?
Yes. The question as phrased here is, what about the precision of geolocation?
Yeah, so both standards are providing support for cellular-based location. From LTE, it may be called of OTDOA, and that is being perceived also by these advanced standards. Obviously, that can be assisted by GPS, but this is not standard-driven. What may be relevant is how to communicate those locations as part of the standard. And this is also one of the challenges by the industry because it is very vital that we reduce the overhead of such reports within the networks, and this challenge is being also addressed by the ecosystem.
Yeah. Here's a good one from a network equipment provider. Is EC-GSM an alternative to Cat-M2? What's your thought on that, Itai?
So this is a good question, and thank you for that. So if we talked about two technologies which provide some challenging by their own, then there is also the EC-GSM, which is the next generation of 2G. This comes from operators that foreseen that the 2G network will keep alive longer than the rest, and they want to make them more suitable for the IoT market. And this is another approach that is being taken. I think that it's indeed something that those operators that will choose EC-GSM, that seems to be something that is suitable for the near term. Moving forward, if and when Cat-M2 will take the dominant approach, I do believe that they will merge into that solution. Everything is being dominated by the cost that the ecosystem will achieve.
Well, Itai, if there wasn't enough evidence from the number of questions that we've got still waiting to be answered, there is a comment here. This is a great presentation. When will Cat-M1 modules be available for sale? And when will chipsets with reference designs be available for sale? I'm going to have to ask you to be brief on this. We've probably got 2 minutes left.
Yeah, I'll be brief. The answer is very simple. We are and our partners or competitors, the way you call it, working full stream towards that approach, and I would expect early modules available as early as this year already.
Okay, probably time for 2 more. Is the assumption of ideal channel estimation realistic when you're comparing M1 and M2? That's from a
no, surely it's not realistic. It's just a matter of simplifying the simulations. What I can tell, in my view, is that if we would have added channel estimation impacts towards the simulation, that will even bring the gap larger in favor of Cat-M1, because we saw that Cat-M1 enjoys a better channel conditions or better capacity, let's call it, compared to Cat-M2. So that means that the accuracy of a real channel estimation being done in a typical scenario will be higher in Cat-M1 compared to Cat-M2. So if we would have added a real channel estimation, not ideal, that the gap will become likely larger.
Itai, I'm going to have to make this the last question, regrettably, but the other questions that have been asked, and there are loads of them, are going to be sent to you later. So last question, is there a plan to introduce frequency hopping for LTE M2?
Yes, I believe it is. It is a good tool, and actually it was discussed in category M2 discussions. However, due to shortage of time and some complexity, eventually it was decided to avoid that within Release 13, and that is likely something that may be present in Release 14. By the way, like other items, there is a list of items that were planned to be added into Release 13, but eventually are being considered to be delayed in sake of time.
You've been commendably brief in your answers, Itai. The next thing I just want to do is just round up, because we're in your debt. The aim of this webinar has obviously been to hear more about how to choose the right standard for your deployment. And I think during this discussion, we've pretty much uncovered some of the key points. There are bound to be more that you want to discuss offline. I know that. So I expect that, like me, you probably learned from Altair's experience here. We are almost out of time. So I would just like to remind everyone who's listening to keep an eye on our website at iot-now.com, because you can stream this webinar from the site very soon, probably within the next 48 hours. And meanwhile, you'll also find the latest news there, plus blogs and videos. It obviously just remains for me to say a big thank you to our speaker. So thank you, Itai. It's been a real pleasure to have you here today.
Thank you very much, Jeremy.
Most of all, ladies and gentlemen, I'd like to thank you for joining us. Wherever you are today, thanks for being with us. Keep safe, and we really do appreciate the time you spent with us. From everyone here at IoT Now, we hope you enjoy the rest of your day. Bye for now.